Okay, guys, time to have a crack at 2019 Exam 1. From what I've heard, some of the algebra in it's not very nice. Some of the things aren't very nice. Um, let's have a look and find out. I've locked myself in a room so no one can disturb me. Okay, you've got to give exact answers. Gravity is 9.8. Solve that differential equation. Okay, so we've got to bring that y to the other side. So 1 on y, dy. I've got to bring that dx to the other side. Stop you stupid thing. So we end up with 2e to the 2x on 1 plus e to the 2x. The reason I kept the 2 there is because when we diff this, we get 2e to the 2x, which works out nicely. So we get log e mod y is equal to log e 1 plus e to the 2x plus c. We've got y of 0 equals pi. So log e of pi equals log e of 1 plus e to the 0, which is 2, plus c. When we bring that to the side, we get c as log e pi on 2. So log e y is equal to log e 1 plus e to the 2x plus log e of pi on 2. So we can multiply what's in the logs. So you get y equals pi on 2, 1 plus e to the 2x. That looks right. Final values of x, which x minus pi modulus is that. So x minus 4 is equal to plus or minus x on 2 plus 7. X minus 4 is minus x on 2 minus 7. X minus 4 equals x on 2 plus 7. 3x on 2 is equal to negative 3. X is equal to negative 2. I'm just thinking, is there some little trick here or something? X on 2 is equal to 11. X equals 22. Very easy for 3 marks. That's weird. Okay, a machine produces chocolate in the form of a continuous cylinder of radius 0.5, so it's got a constant cross-section. Small cylindrical pieces are cut, so that's that chopping there. As shown in the diagram, the lengths of the pieces, so that's that there, will vary with a mean of 3 and a standard deviation of 0.1. Find the expected volume. So we know V equals pi r squared h, in this case L. So E of pi r squared h is equal to pi r squared times E of h. So pi times a half squared times 3. So 3 pi on 4. Does that make sense? I think it does. That's very different. Centimeters cubed. Find the variance of a volume of a piece of chocolate. So the variance is based on the height, because, so we want var of pi r r squared h, which is pi squared r squared var of h. Var of h, we know the standard deviation is 1 on 10, so that's 1 on 100. So we get pi squared r, what the hell is r, half. Oh, that should be out of the 4, because I've got to square it when I take it out. So 1 on 16. The variance of h is 1 on 100, which is pi squared on 1600 centimeters to the 6. Very different. Find the expected surface area of a piece of chocolate in centimeters squared. So we know total surface area is 2 pi r plus h. So we know it's just 2 pi times a half plus a tenth. Find the expected surface area. Oh no, the height's 3. Pi plus, because it's r plus h. H is 3, or the expected value mu is 3. So from here we get pi times, they cancel, 3.5, which is 7 pi on 2 centimeters squared. A little bit weird. Okay, position vectors, particles A and B, time t seconds after they have started moving, given by that and that. A is a real constant. Find the value of A if the particles collide after they've started moving. So if they collide, they're going to be in the same place, same x value, same y value at the same time. So let's let x of A is t squared minus 1, x of B is t cubed minus t. Therefore, t squared minus 1 equals t cubed minus t cubed minus t squared minus t plus 1 equals 0. Okay, t squared, t minus 1 minus t minus 1 equals 0. So t squared minus 1, t minus 1. So t minus 1 squared, t plus 1, t equals 1 or negative 1, t is greater than 0, therefore t equals 1. So we know y of A is equal to A plus t on 3, and y of B is equal to cos inverse of t on 2, when t equals 1, A plus 1/3 equals cos inverse of 1/2 pi on 3. A equals pi on 3 minus 1/3, or pi minus 1 on 3. Cos squared x plus cos x plus 1 over the domain that is shown below. Find f dash of x. Okay, cos squared x we know is cos of x all squared. So f dash of x is, bring your 2 down to the front, derive cos, negative sine x, cos x, derive cos, negative sine x, derive 1, you just get 1. So we can say that this is equal to negative sine x to cos x minus 1. Find the coordinates of the turning points of the graph. sine x equals 0, 2 cos x minus 1 is 0, x equals 0, pi, 2 pi, domain, we can scrap those, so x equals pi. Okay, that's a plus, which means that's a plus. 2 cos x is negative a half. 1, 2, pi on 3, and it's in the second and third quadrant. So x is 2 pi on 3 and 4 pi on 3. Okay. Turning points. So we've got pi, we put pi back into the original. Cos of pi is negative 1, squared is 1. Then I get negative 1, which is 0, plus 1, which is 1. We have 2 pi on 3. Cos of 2 pi on 3 is negative a half squared, which is a quarter. And then negative a half plus 1. Negative a quarter plus 1, negative 3, it's 3 quarters, 3 quarters, 3 quarters, which looks about right on the graph. So 3 on 4, 4 pi on 3, 3 on 4. Sketch the graph of 1 on f of x, clearly label the turning points, endpoints. Okay, this should be pretty easy. 1 on 3, 1/3. So, okay, so 2 pi, 1/3. 1 on 1 is 1. 0, 1/3. 1 on 1 is 1. 1 on 1 is 1. That value, what's that? 3 quarters, so it's going to be 4/3. And 4/3. So turning points, pi 1, 4 pi on 3, 4/3. 2 pi on 3, 4/3. It's going to get up like that, over like that, like that, like that, and then down like that. Endpoints. Clear label turning points and endpoints of the graph with their coordinates. Okay, that's all done. Okay, find the value of d for which the vectors that, and that are linearly dependent. Okay, 2m minus 2n equals negative 6. Negative 3m plus 4n is equal to 2. 4m minus 8n is equal to d. 1, 2. So if we have 2 times 1 plus 2, okay, so 2 times 1 plus 2, that's going to give me m. Nothing n is equal to negative 10. If we put negative 10, we get negative 20 minus 2n is equal to negative 6. Negative 2n is equal to 14. N is equal to negative 7. Therefore, 4 times negative 10, negative 40, minus 8 times minus 7, which is plus 56, equals d. So d equals 16. If d equals 16, they are linearly dependent. Okay, 6 down. Show that 3 minus root 3i is equal to that. So r is the square root of 3 squared, root 3 squared, which is root 12, which is 2 root 3. Tan theta is equal to negative root 3 on 3. Theta is equal to negative pi on 6. Therefore, 3 minus root 3i is equal to 2 root 3 cis negative pi on 6. Find that to the power of 3. So we can say 3 minus root 3i to the 3 is equal to 2 root 3 to the 3 cis negative 3 pi on 6, which is 8 times 3 is 24 root 3. Cis of negative pi on 2. Of course, if you go around negative pi on 2, it's just going to be negative 24 root 3 I. Find integer values of n such that that's real. So if it's real, it's got to have no imaginary component. So we know that cos of our angle, so we don't really need to do anything because it's 1 mark. We know that cos theta plus I sine theta, so I sine theta has to equal 0. So we know our angle, it would be 2 root 3 to the n cis negative n pi on 6. Therefore, negative n pi on 6 has to equal, so our cos theta plus I sine theta, our imaginary part has to equal 0. So sine has to equal 0. So that'd be 0 pi plus or minus 2 pi plus or minus. So we'd say 0 plus k pi, which is we don't need to worry about the negative. N pi on 6 equals k pi. K is an element of z. So therefore, n is equal to 6k. K is an element of z. So if n is any factor of 6, when you put it in, we're going to end up with just a real solution. Okay, find integer values where it's imaginary. So we've got the same thing, 2 root 3 to the n, cis negative n pi on 6. Therefore, negative n pi on 6 has to equal plus or minus pi on 2 plus k pi. We can forget about the negatives. K is an element of z. Okay, so if we divide the pi across and multiply the 6 across, we get n is equal to 3 plus 6k. K is an element of z. So let's test it. K equals 0, we get n is 3, which means we get negative pi on 2, which is imaginary, but no real part. K equals 1, we get 9 pi on 6. 9 pi on 6 is negative 3 pi on 2, so they always, yep. So that's our answer, 3 plus 6k. K is an element of z. Okay, find the volume of a solid of revolution formed by that when it's rotated about the x-axis over an interval of 0 to 1. So, 0 to 1, pi, 1 plus 2x, because we've got to square that, 1 plus x squared dx. Now that looks like we've got to separate it. 0 to 1, 1 on 1 plus x squared dx, plus 0 to 1, 2x. These both work out nicely. Maybe the badness is coming. So we've got pi tan inverse of x between 1 and 0. Pi tan inverse of 1 is pi on 4. Tan inverse of 0, 0, plus pi log e 1 plus x squared between 1 and 0. So plus pi, I'm going to get log e2. When I put 0 into that, I'm just going to get 0. So we get pi squared on 4 plus pi log e2. There's no form that has to be in. Units cubed. Okay. Oh, that's it. We could have taken pi as a common factor in the 4 if we wanted to, but who can be stuffed? Okay. The light extensible string is connected at each end of the horizontal string. A massive m kilos hangs in equilibrium. Shown in the diagram, string makes an angle of theta with it. Okay. Express the tension of the string in terms of mg and a. So we've got, there's t, there's alpha. So this is t cos alpha. There's t cos alpha. And we know that this is mg. And we know we're going to have t sine alpha here, and then t sine alpha here. So we get 2t sine alpha. So 2t sine alpha is equal to mg. So therefore t is equal to mg on 2 sine alpha. Okay, a different light extensible string is connected at each end of the horizontal ceiling. A massive m kilos hangs from a smooth ring on the string. Horizontal force F newtons is applied to the ring. The tension in the string has a constant magnitude and the system is in equilibrium at 1 and the string makes an angle beta. Okay. So, what have we got? There's 2 beta. So this is F plus cos 2 beta. And this is cos 2 beta. This is mg. Okay. And it's in equilibrium. So this is going to be, that's t, that's t, that's t, that's f plus t, I forgot the t's. Okay, so that'll be, this component upwards will be t cos 2 beta, and this will be t sine, beta, sine 2 beta. Okay, so what do we know first? We know t sine beta plus t sine 2 beta is equal to mg. So we can say that t is equal to mg on sine beta plus sine 2 beta, which we know is mg on sine beta cos, 2 sine beta cos beta. Sine 2x. Actually, we'll leave it and do it later on. So that's t. So then, if it's in equilibrium, we know that f plus t cos 2 beta is equal to cos beta, t cos beta. So we get f is equal to t cos beta minus cos 2 beta. Okay, what can we say? F is equal to t cos beta minus 2 cos squared beta minus 1, which we know t negative 2 cos squared beta plus cos beta minus 1. Okay, so t, let's factorize this thing. Negative 2 cos beta and then cos beta. We've got to have 1 and 1. So minus 1 plus 1. Okay, so we've got equals t let's take the negative to the other one. So 2 cos beta plus 1, minus 1, 1 minus cos beta. Okay, but we know that t equals mg, so therefore f is equal to 2 cos beta minus 1, 1 minus cos f mg, which is that. Stupid thing. Okay, so on the bottom we've got cos beta here. Okay, sine beta plus sine 2 beta. Sine beta plus 2 sine beta cos beta. What the hell have I stuffed up? Oh, that's a plus 1. That kind of stuffs up the whole thing. Okay, so equals negative 2 cos beta minus 1 and then cos beta minus 1. What the hell is it? Minus 1, which is t 1 minus cos beta, which is what we want, and then 1 plus 2 cos beta. Okay, so if we change this, 1 minus cos beta, and then 1 plus 2 cos beta. You can see if we take out sine b on the bottom, we get mg 1 minus cos beta over, that will cancel with the other one. So we end up with sine beta, which is what we want. I hope you understand what I just did. So I couldn't be bothered writing it. If we take out sine beta, we're left with 1 plus 2 cos beta, and then that will cancel with that. So we just end up with that. Okay. Last question. This is the one that I think is a bastard. Okay. Find dy dx at the point that, for the curve defined by sine x squared plus cos y squared. Okay, so we've got to do implicit differentiation. So to diff this, we get 2x. When we derive sine, we get cos x squared. Plus, when we derive y squared, we get 2y. When we derive cos, we get negative sine y squared, but we need to add a dy dx because we derive with respect to y. That's equal to 3 root 2 on pi. Derive x, we get 1, so we just get y. Plus, if we derive y, we get dy dx, so x times dy dx. Okay, so that's that done with implicit differentiation. I don't think I've missed anything. Now let's sub in the points, because I think it's going to be a bastard if you don't. Okay, so x equals root pi on 6, y equals root pi on 3, so 2 root pi on 6 cos of pi on 6 is root 3 on 2, so times root 3 on 2 minus 2 root pi on 3. Sine of pi on 3 is root 3 on 2, dy dx. Okay, that's equal to 3 root 2 on pi, y, which is root pi on 3, plus x, root pi on 6, dy dx. Okay, that's a start. Now what do we do? So we'll simplify as much as we can and then see what happens. So that 2 cancels with that. We've got a 3 inside a root and a 6 inside a root, so we're going to get root pi on 2. That's going to cancel with that. My root 3 and my root 3 are going to cancel, so I just get root pi dy dx. That is equal to, when we multiply this in, so I'm going to rewrite this to be root 18. So I get root 18 on 3, which is root 6. And then I get root pi on pi, which is root pi on the bottom. So root 6 on root pi. And then plus root 18 on pi times root pi on 6. I'm going to get a 3 on top and a root pi on the bottom, dy dx. Okay, so from here, let's bring our dy dx to one side. So dy dx, root 3 on root pi plus root pi. So I brought this to the other side. And then that's equal to root pi on root 2 minus root 6 on root pi. Okay, with this, I'm going to put that over root pi, so plus pi on root pi. So we get dy dx root 3 plus pi on root pi equals, now let's put these on a common denominator. So if I add a root pi on the bottom, I'm going to get pi root 2 pi. Here, if I add a 2 on the bottom, I'm going to put a 2 on the top, so I get root 12, which is minus 2 root 3. Okay, now we've got to divide that to the other side, which is the same as flipping and timesing. So dy dx is pi minus 2 root 3 on root 2 pi times root pi on root 3 plus pi. So that will cancel with that. Is everything right? Okay, so what would we get? We would get root 2 pi plus root 3 on pi minus 2 root 3. So pi minus a root b on root a pi plus root b. So a is equal to 2, b is equal to 3. Bloody hell, that was stupid. That hurt my brain. I don't even understand why you would do that. But hopefully that's right. I hope you guys enjoyed that one, because I didn't. Hopefully you did alright. Good luck for exam 2 on Monday.